Hello, this is Professor Timothy Kentop, and this is Section 1 of Solution 2 in CSC 239, Scientific Computing Applications. The first thing you're going to want to do is to resize the window that you have running for your virtual machine, whether you're using your own Linux version or the PGBook VM 2020 version. I would suggest that you first select Scaled Mode and note the pop-up that tells you which control key and C will bring you back there. And then go to your system settings and then access displays and then switch out of 800 by 600 and choose something with a little width and a little more depth. 1280 by 768 is good for most laptop screens, most conventional laptop screens. You want some real estate on your desktop as you work with your Module 2 solution, because one of the things about a terminal is that it's all character-based. There are many things that we take for granted in using most of our modern mobile devices and portable technology. We drag and drop windows and they resize automatically, and they resize the elements and arrangements automatically. And many of the terminal commands, one of the challenges of working in the terminal environment is arranging a terminal with enough real estate, enough width, enough spacing to allow the output to be seen plainly. You'll see an example of this shortly. We're going to open our terminal prompt and we'll proceed with the first set of tasks, and at some point you're going to see that, oh, the terminal width that we're using is not the best for what we want. Our first task will be to create a series of directories, a parent directory in our home directory called mod2 solution, and we're going to use camel case. And the first thing you're going to want to do, and then inside that directory we're going to create two child directories, one for data and one for programming. So we'll use the same command in each case, and it'll be advantageous to use the repeat command option with the up arrow key or to view history to do some of this. So in any case, we're going to make directory using mkdir, make directory mod2 solution. And I want to create the two child directories within the parent directory, so I have to navigate inside mod2 solution. If I don't do this, creating the data and programs directory at this point will actually create brother and sister or sibling directories, adjacent directories, instead of a subdirectory. So I'm going to cd space and then mod2 solution. And now you see my prompt has changed to indicate that I'm in the directory mod2 solution within the home directory. That's what the tilde stands for. I'm going to repeat the same command twice, except I'm going to substitute. So I'm just going to hit my up arrow until I get to this. Then I'm going to backspace and enter data, and then repeat again and backspace and enter programs. And what we want to do next is redirect the output of a list command to a data file. And I want you to do this with your first initial and last initial. So the example that I give, I want you to follow, but I don't want you to put TK. I want you to use your first initial and your last initial. I'm going to use TK, so I'm going to say ls-al, and then I'll use the redirect operator, and I want to use that output. Well, all right, so first, instead of redirecting the output, let's look at what the output would show, and then I want to capture that output to a file. So let's just have a look. We're going to use this command over and over again. Okay, so here's what you see inside mod2 solutions. You see two directories, one called data and one called programs. And again, there's no other files in there right now because, and that's what this shows right here. The D's mean directory. So I'm going to create a file by using that output and redirecting it to a file called tk directory 1.out. So this is the first directory. And now if I repeat the command to list the contents of the mod2 solutions directory, you see I have a new data file. I've captured the output, created a data file, and I have read and write privileges, but not execute privileges because it's not an executable data file. And if anyone's in my group, they have similar ones, and anyone else in the world can read it. And that may or may not be good. We'll get to that in a later section. What I'm going to do next is create a second directory output file. So I'm going to repeat the same command here, and I want to capture the contents from here to here in a second data output file I'll call tk directory 2out. So I need to repeat that same command and just make a modification. I'll use my left arrow key to get near the 1, and then I'll backspace over it and put a 2 in. So there we go. I'll backspace over this. I'll put a 2. I'll hit enter. And now, if I look at the contents of my directory, I now have 2 output data files. And the second output data file should be different than the first one. The first one only shows data and programs. The second one should show tk directory 1.out. To verify, I'm going to use the cat command just to display the contents of those 2 output data files. Cat tk directory 1.out and cat tk directory 2.out. It almost looks similar, but what you have to realize is that this is the start of a new terminal prompt. The contents of this file, tk directory 1.out, run here. And the contents of tk directory 2 run here. And it's okay to do this manually. Oftentimes you have to distinguish between data elements, unique data elements in 2 data files. You want to find the difference. There's a lot of similar data elements in files as you collect them in the Linux terminal, and the problem is that you want to quickly identify which ones are different, which data elements or which part of the data file is different. You can do it manually like we've done, but that's not the most efficient way to do it. The most efficient way to do this is to use the diff command. And I'm going to use a specific switch to show the 2 side by side, and I want diff to point out the difference for me. And this is where the screen real estate and your terminal width matters. So just to get back to that, I'm going to use diff and then dash y and then tk directory 1.out and tk directory 2.out. And you see that command runs off the screen and then wraps down to the bottom. And then when I hit enter, I'm going to get a response, and that's going to cause problems. And okay, I get some kind of output but it's wrapped around. It's harder to see what's going on here. It's harder to make out. What I want to do is have enough virtual machine display to do something like this. And that's the advantage of capturing, in case you're wondering. Sometimes the display doesn't show as well for output results. There we go. That's exactly what we need. It's much cleaner. The advantage of capturing or redirecting output to a data file is that it is easily viewable, and you can pick things out in other programs where in the terminal it might be hard to do. So this is a very simple example. You can have very wide, very long data files that accrue, and you want to be able to work with these efficiently. Here is the first part of the data file. So in this diff option with a tac y, and that's the lingo of the Linux gurus. So you've learned already that bang is an exclamation point. Dot is you use the word dot instead of period. You don't use hashtag. That's a pound symbol, right? Pound bang, and then this is tac instead of dash. If you want to sound like a real hacker or somebody that's working in the industry, that's the lingo you use. You see the first file, directory1.out, displayed on the left side. Total is 16 here. You see the second file displayed on the right. And here's the point of interest. It calls out. Diff calls out the element that's different. So you let the system do the work for you with much larger and much deeper data files. This is really handy, and it's a much more efficient way to work. And so what you want to do at this point is grab your screen and get a screenshot of your section 1. So this is what we want to show for section 1. And you should have something similar on your screen. But in order to produce this result, you have to follow the steps. So if you don't have all the rest of this up here in your screenshot, don't worry. I just need you to highlight this. And then with this window showing, if you click outside the window on your desktop, then you're able to use Alt print screen, well, actually just print screen. Then you can clip the image out, and that's what you submit for section 1. So that's what I'm going to do now. I'm going to hit print screen, and then I have what I need to paste into my Word document for section 1. This concludes section 1 of solution 2.